Next, that is question number 6, says for the coupled circuit shown in figure, find input impedance at terminals A and B. The diagram given is V1, this is 3 ohms, A, G2, G4, minus G6, G3. Now again the current is entering in the both the coils in the same direction. We can draw the diagram with the induced EMF. Terminal B, V1 plus minus, and input impedance, that means I1. Input impedance, that means we need to find the ratio of V1 upon I1, even if it is not given in the question. Input is V1 upon input impedance is V1 upon I1, G2, and this will be positive negative, because the direction of the current in both the coils is same as the flux. G3, I1 minus I2. Suppose I1 is flowing in this, I2 is flowing in this. Current flowing through J4 is I1 minus I2, so we take it as J3 into I1 minus I2 minus J6, and this is induced because of this coil, that is the current flowing through the coil is I1, so we have taken it as I1 here. Now our aim is to find V1 upon I1. So first I'll apply KVL to mesh 1, the first mesh. V1 minus 3 I1 minus G2 into I1 minus G3 into I1 minus I2 minus G4 I1 minus I2 minus G3 I1 equals to 0. So on simplification we'll get 3 plus 12 I1 minus G7 I2 is equal to V1, calling this as equation 1. Now KVL to mesh 2, so that will give me G3 into I1 minus G4 I2 minus I1 plus G6 I2 is equal to 0. On simplification we will get it as G7 I1 plus G2 I2 equals to 0, or I can say I2 will be minus 3.5 times I1, so calling this as equation number 2. Now I'll substitute 2 in 1. Now why I found only I2 in terms of I1, because if I substitute I2 in terms of I1 I'll get V1 by I1, so I'm writing I2 in terms of I1, So after substituting here, straight away I'll find V1 by I1, which is nothing but the input impedance. So I'll substitute I2, which is minus 3.5 in equation 1. So it will give me 3 plus 12, 3 plus 12j I1 plus j7, 3.5 I1 is equal to V1. So after simplification, we'll get it as 3 plus j36 I1 is equal to V1. So you'll get V1 by I1 as 3 plus j36. So that is nothing but the input impedance, and that will come to 36.48 angle 85.28 degrees ohms. So this is how we have found the value of the impedance.